Okay, so today, so we are going to like have this webinar session on Microsoft AI Challenge. So myself Harish Yanalla. So I am a data scientist here in Microsoft IDC Hyderabad, and I have one more like speaker here, Rajarshi Mitra. He is also working as data scientist in Microsoft IDC Hyderabad. So today we will be talking about like the ways to improve your models. So since the competition is has already started, so some people are near to baseline one, some people are near to baseline two, and some people have crossed baseline two also, and at the top and all. So we will be giving, since the like deadline is very nearer, so we wanted to give you some like quick wins. Like we will be telling you some uh, simple techniques which if you have added into your models and all, then you will be able to improve your models and get good scores. So we have categorized all those techniques into these things. So like the first one is pre-processing. So we can improve your like text pre-processing, which is the main step because that will affect other steps in the pipeline. So we have come up with some pre-processing techniques, so that might help you improving your model. So we are sure like some of you might have already done those pre-processing steps, but still if you have missed anything, you can still use it. And we also suggest some extra features to use, so which will help you, which are simple features, but that will completely boost your model. So and we will be talking about like how to handle the data since it is so huge, and how to select the best data. So that sampling techniques or something like that. So we will be talking about them too. And we will be explaining various embeddings available. So in baselines we have mentioned only glove embeddings. So you can try out other available publicly available embeddings also. Um, and in the like in the end we will be talking about the latest models, latest trends in this area, Q&A area. So this will mainly help you like whoever are trying like baseline 2 like deep models and all. So those can try out these latest models that are currently used by like researchers now. So we will be talking about them as well. So first one is pre-processing techniques. So as I've already explained you, so um, so the first two steps like pre-processing and extra features, this will help you improving mostly on the baseline one. And this data selection will be useful. Data selection and handling the big data will be useful for everybody. And this embeddings, trying out new embeddings and getting to know the latest models, architectures and all will be helpful for whoever is trying for deep models and all. Okay, so first two will be might be very familiar for many of you, but still we wanted to cover like everybody, so we are explaining those things as well. So the first one in pre-processing is lower casing. Like this thing is known to everybody, so everybody will use this. So since the data will be in capitalized format and some of the data will be lowercase, some of the data will be like uppercase. So we will convert query and all passages into lowercase. So that will help in like, let's say if you are finding number of matchings. Let's say there is a word like apple in capital letters in query, and in passage that same word apple is there in the small letter. Then so you can't compare them directly. So try to convert everything into lowercase, then you can find a word match there. So yeah, that is everybody familiar with. And next step is tokenization. So in tokenization, if you see baseline one, there we have used space. So with space, we will have some problem. Let's say if I have a sentence like this: Hi, good morning, how are you doing? So if I split this entire sentence or the query, or the passage with space, so then hi comma will be one word, good will be one word, morning and explanation will be one word, how are you doing, and doing question mark will also be one word. But let's say if I want to use word representations, so in that case, like I can't find an embedding for morning and explanation, right? So in that case I need to remove this. in that case, I need to remove this explanation mark and consider only the word morning. So for that, we can't use space as a delimiter to split the sentence. So for that, like if you see baseline 2 in the text processing, we will be using like slash w plus as regex. So this regex will make sure that like wherever some symbol comes, like non-alphanumeric symbol comes, character comes, then it split with that. That in that case, like we will be coming up with like hi as one word and comma as one word, good morning, and then explanation, how are you doing and everything. So but is this the right technique to do? No, because like if we see one more sentence here, like my uncle works in a cooperative bank. So here cooperative will be splitted. If I follow this regex, cooperative will be split into co and operative. So which is actually like not making sure that cooperative as a one word, right? So we should to get this cooperative as one word, so we should use something called word tokenizer, which is available in NLTK. So I think you all know this NLTK package and will be able to use this word tokenizer. But still, I can explain you. I can show you like quick demo for that. Uh, So here I have imported like word tokenizer and sentence tokenizer. So we will be recommending you to use these things to get like better text input for your model. So you can write NLTK dot of, let's say, okay, I will import NLTK first. So now we can see that cooperative is together as a word. So yeah, this is the advantage we get if we use the like NLTK word tokenizer, or sentence tokenizer is also available if your model needs sentences as the input. Okay, now let's go to the next technique, that is stop words removal. I think this is also like this technique is also known by everybody, but still I will explain with some example here. So in this technique, we will be removing all low important word. Like if we take any article, if we take any book, if we take any like in our problem also, if we take any query and different passages, so the commonly repeated words will be is, are, am, and all, right? So we will be removing those words so that like they are not important. So we can see with this example why they are not important. So the query is, who is the first prime minister of India? So I have two passages. The first president of India is Rajendra Prasad. First prime minister of India Jawaharlal Nehru. So in these two passages, I have five word matches with query. So in passage one also I have five word matches, like the first of India is, and passage two also I have five word match, first and Prime Minister of India. But which one we will be taking? Second one. Why? Because the main words, like non-common words, are Prime Minister India. These three are matching in this. But whereas here only India is matching. India, which is like high important word. So here, though there are like non-important words are matching, we don't consider that. So using the stop words removal technique, we will be removing all these like high frequent words or low important words and compare only the important words. And then we can talk, there is one more technique, one more preprocessing technique, that is stemming. So if your query contains something like who is talking today in the seminar, and in the passage you have like he talks in the seminar, or he will talk in the seminar, or something like that. So then you should have a word match for talking to talk. So how will you get that word match? Do using stemming. So stemming is a process which removes all prefixes and suffixes and brings to one like basic raw word form. So talks will be converted into talk and talking will be converted into talk. So using this you can avoid those like non-word matches with talking and talk. And there is one more thing, lemmatization. So let's say if I do stemming for the word studies, so I will be sorry, this should be I. Here if I do stemming, it will give me studi. But if I do for studying, if I do stemming, I will be ending up with study. Here studi and here it will be studi. So even after doing stemming, I can't compare studi and studi, right? So that's why we will do something called lemmatization. So lemmatization will give you the actual root word. So the like root word where like these inflections are originating from. So for studies, this is the root word, and for studying, this is the root word. Though this is stemming is simple to implement, but this is more helpful. Lemmatization more helpful. Stemming you just need to know all inflections like es, yes, ing, form, and all. Then you remove those things. Then you can build a stemming. But lemmatization needs like more efforts to create. But in comparison, this is the best useful technique than stemming. So I can show you how that works also. So I am using these two, stemmer and lemmatizer here. So let's say we stem or dot stem of, so talk, it will be talk, this will be talks. If I, this is how like stemmer you can call. And how do you call lemmatizer? Lemmatizer dot lemmatize of, we were thinking of example this studying, right? And for lemmatizer you have to give the parts of speech of it also. So pos tag also you can find from nltk, so you don't need to like manually give it, you can find it. So here I don't want to run pos tagging, so I am directly giving that I want to find the verb root of the studying. So then study is the answer. For studies also study. So this is how we can use lemmatizer and stemmer also. Now yeah, demo is done. So one more thing is like we can second category for improving your models is like extra features. So adding extra features to your model. So we have this TF-ID of our BM25 baseline, right? So using that as a feature and adding some more features, you can train a binary classifier. So using the score from BM25, score for query passage, so you will get a score. So using that score as a feature and adding some more features, you can train a binary classifier. So let's discuss about what are those other features we can add along with this BM25 score. So one of them is like named entity recognition. So that is a technique which gives you information about like if you give a passage or a query, it will tell what is the location there, whether there is a location entity or not, organization is whether it is present or not, whether date is present in that, whether money is present, percent time, etc. So it will give these type of presence of all these parameters. So let's say this is my sentence. Microsoft was founded by Bill Gates and Paul Allen on April 4, 1975 to develop and sell basic interpreters for the Altair 8800. So in this, when I ran my like named entity recognizer, it told that this is the organization and these two are persons and this is the date. So I can have these as my features, whether location is present in my passage, whether organization is present, where date is present, money is present, and all. So how will it help? That we will know in the next thing. So but you can think that these are the features. And one more feature you can use as answer type detection. So if there is a question like where is Taj Mahal built, so this is the query I have, but what is it expecting as an answer? Location, right? So there are some classifiers which will take the query as input and give what is the expected answer, what is the type of expected answer, that is answer type, location. So for the query who is the president of India, the answer type will be person, right? So we can make a good feature combination using these two, named entity recognition and answer type detection. Okay, so how that will be done, we can discuss here. So answer type and NER. So let's say if I have a question, who invented bulb? And Thomas Alva Edison invented bulb is my passage. So then from this query, I will know that my answer type will be person. So if I pass this passage to my NER, I will know that there is one person in my passage. Let's say there is one more passage I have for the same query that is not talking about person at all. Some that is talking about today's date is so and so. So in that there is no person entity, but in this passage I have person entity. So I will choose this one over that passage. So that is like combination of these two, answer type and NER, will make a good feature set. So we can see the second example also, where will be the 2019 Cricket World Cup. So 2019 Cricket World Cup will be held in England. So this query will tell us that answer type will be a location, and in from this passage we can know that from NER we can know that there England is a location. That means there is a location entity in my passage. So next thing, so when will be the next parliament election in India, and there is date. So here this is expecting date, and in my passage there is a date. So I'll choose this passage compared to the other passages where there is no date at all. So this is fine. So to like to build this classifier, and also especially for answer type detection, you might be thinking like whenever who comes, like we can expect a person, and where comes we can expect location, when will be related to date and all. But that's not true always actually. Like you might get this type of query in your data, like which are what country gave New York the Statue of Liberty. So here like which are what, these two will not tell us anything about what is the expected answer, right? Answer type. So in that case you can use, there are like there are some papers, I'll give you the reference also, but answer has location anyways. But this answer type of this one, like we will think like whenever there is where comes, then only the answer is location. But here there is no where, but still the answer is location. So for that type of thing, there are some papers where you can implement, or there are some already implemented GitHub repositories. You can find, just type like answer type detection. You will get some of the implemented models and repositories. From there you can directly get this info, answer type detection. And for NER information, so there is a like Stanford publicly available API also. You can use that. So I'll give you that. Uh, so this is the link for that Stanford named entity tagger. So yeah, so let us give these examples only. Thomas Alva Edison invented bulb. It is running. Usually it's not this slow. So I had already run this one. The second example, 2019 cricket will be held in England. So England is matched with location, right? So we can get this info if we pass the passage to this. And okay, let it run. We can come back and see the output for this. So basically it will tag this part as the name. So the name person color is this one. So it will give that color to this Thomas Edison. Um, so yeah, that is, so this like combination of answer type and NER will make a good feature set, and that will like really give you like good jump in your numbers, precision and recall. So for answer type detection, you can like search online also, you will get paper, but I can show you one paper. Uh, so you can also read or implement that paper. Or you can find like a pre-built, pre-implemented repositories also. Yeah, so this is the paper, learning question classifiers. So there you have, so this classifier will give you like like broad level categories like abbreviation. It is asking for a description, or the answer should be numeric or location, human, and all. And there are 52 like fine grained classes also. If you want in detail class like answer type, then you can get this also. So the paper name is learning question classifiers, the role of semantic information. Yeah, so let's know other features. Yeah, so usual features everybody that everybody uses are like top k unigrams you will take, and bigrams also. If you want, you can take trigrams also. Like you can experiment with different combinations and see. So this k also you should decide based on your numbers, performance, and the data and all. So I hope you all know the unigram bigram concept. And then next, query length and passage length. So for this I have an example why we have to consider query length as a feature and passage length as a feature. So the question is how many prime numbers are there between 1 and 100, right? And one more question, I have a passage one. So this is talking like this is telling like there are two types of numbers, prime numbers, composite numbers. A prime number is so and so, and in between we have our actual answer also. Hence the total prime numbers between 1 and 100 are 25, and one is not a prime number because so and so. Yeah, and the second passage is talking directly like there are 25 prime numbers between 1 and 100. So which passage you will choose? Like if you are a user and you are given with these two passages, which one you will choose? So obviously this one, right? Because this is pretty straightforward, and like whatever the answer that whatever the question that I asked, this is answering my question. So I am happy with this. So I don't use this. So sometimes like we expect like passage length should be less. So that's why we can take like query length and passage length as features. So they will also contribute in the like improving the model. And matching words, everybody knows like how many matching words are there between like query and passage. So this is like I'm sure like everybody uses matching words. So that we have already discussed about these matching words also in this example, right? The president prime minister example. Yeah. um, and after that there is a very good feature, position weighted n-gram score. So let's say if you observe your data, you will know that like always we will have positive label. That means choose an answer is straightforward answer than some extra content. So here I have like complete extra information that I don't want for my question. So when I'm asking like how many prime numbers, that means I know what are prime numbers and all. So I will not be interested in knowing what is prime number and all. So I will be always interested in taking the straightforward answer. So this position weighted n-gram score will make sure that you have straightforward answer. How will it do? So this one will be like this one will calculate one score for query passage pair based on taking their position matches. Let's say in this like how many let's think that these two are like staff words. So prime numbers are my main words. So where this prime is matched in my passage. So the word prime is matched here. That means after some time, right? After some 1, 2, 3, 4, 5, 6, 7, 8. So this is at the eighth place. So my score for prime will be 1/8. But whereas in this case 1, 2, 3, 4, 5. So for passage 2 my score will be 1/4. This is at the fourth place. So 1/4. And for numbers also I will get here, and between is there here, but between is there like at 1, 2, 3, 4, 5, sixth position only. So my score will be 1 by position number. That means so for straightforward answer I will get good score, better score than like unnecessary information like having passage, right? So this is about that feature, like position weighted n-gram score. So next is similarity scores. So you can also use similarity scores. How will you get this similarity scores is, so there are some sentence representation techniques available publicly and online also. So if you use those, okay, so for example, there is a pipeline called DSSM. So this is we have paper also for this. So this DSSM will if you give any query or a passage, it will give you one representation, 300 dimension representation. So using that 300 dimension representation for query and for passage, you can find the question similarity between them and get a score. And I can give you one demo here. So this is like, we call it as send to wake. So these are like DSSM and CDSSM model. I will also tell you like where to download this model from. So let's say for here, okay, so okay, so I can tell you where to download this from, but I'll give you a demo how to run this. So there is pairs.txt where you need to give query and passage. After that, you just run this run.bat file, and you will get all the vector representation and also scores. So let's say that we'll take the same example. Who invented bulb? And give a tab separate give a tab space, and then type your passage. Let's say Thomas Edison invented bulb. And for the same query, so I want to write here Thomas attended a meeting today. So this is irrelevant passage to the query, and this is relevant passage to the query. Let's see what scores we get for this. So now I have page.txt. I'll run this run.bat file. So yeah, it is over. Now we got so when you have CDSM outs, these are the scores, CDSM scores, and these are the DSM scores. So yeah, so these are the CDSM score. For the first one, I have like 0.55 score. That means more matching is there. For second one, we have 0.23. That means that passage is less relevant to the query. And if we take DSSM scores, so yeah, these are the DSM scores. So zero point 0.6 is for first one and zero point 0 is for second one. So these two are two techniques where you can find the similarity scores. So similarly, you can find different techniques where you will get these scores and use them as features for your classifier. Query passage similarity scores. And you can also do, you can also take word level embedding. Let's say we have glove embeddings, right? So you can take, like, this is just an idea you can try out. So we have glove embeddings for how many prime numbers and all. So take glove embeddings for all the words in the query and average it, and then you will get a vector. And for passage also take word embeddings of all the words in this passage and average them, and then also you will get one vector. So one vector here, one vector here, find a cosine similarity between these two, then you will have a score. So that will represent how similar these two are. And similarly do this for passage query and passage 2, then you will know which passage is more related to query. So that way you can do for word level also, using not only glove, fast tag, word to wake, and all. You can use any other embeddings and find the representation for sentence using averaging or summation and all, whatever you want to do. Like finally you should represent the entire query using those embeddings. And similarly for the passages, then find the cosine similarity between them. That will be your similarity score. So take all the similarity scores and add them as a features. Like take query length, as them as a feature, passage length, add them as feature, and matching word, number of matching words will be a feature. So this score, position weighted score, is also a feature. And these are number of unigrams present, like whether that kth unigram is present or not is a feature. Kth bigram is present or not is a feature. And we have already discussed in the previous slide whether those NERs are present, whether location is present or not. So these type of features, and answer type feature. So if you use all these features and train a classifier, so that will perform better than using only the BM25, which has like only, you can say that it has only one feature now, like which is BM25 similarity score. But now if you use all these and train a classifier, I will get better results. And you can also do this ensembling techniques. So let's say ensembling techniques, you can do different, you can take different classifiers score. Let's say you have two classifiers. One is your BM25 classifier, and second is your like our baseline to deep learning classifier. So take those two scores and train one more binary classifier out of it, one more classifier out of it, or else take those two scores, like let's say you have BM25 score and also like deep learning model score. So for every query passage, you will have these things. So do the average score, find the average of those scores and try to see the performance of that. So you can do two ways. Either you can use them as features and train new classifier, or directly use those scores, average them, and treat that as a final score and see the performance. So that is about ensembling techniques. Yeah, so these are mainly these two techniques are mainly like adding features and also pre-processing techniques are mainly to boost your like baseline one model. And in while you are training your deep learning model also, especially that pre-processing technique is useful. And for those who are doing like like building a classifier or using deep models, so for deep models we will be giving some embedding as an input, right? So along with that embedding, let's say I am giving glove embedding. So along with that embedding and like representation, glove representation of word how many and all, so along with representations of everything, add extra features as these features like manual features that you find here. So deep features plus handcrafted features, that will give better results than using only deep features. Yeah, so these are the techniques which will mostly help for baseline one, like the participants who are nearer to baseline one. So now Rajarshi will talk about other like deep learning techniques and other like complex techniques which will actually give you a big jump over your numbers and all. Um, yeah, Rajarshi, you can enter.
Hey, hi. Am I audible?
Yes, you are. Rahul.
So, yeah, Harish, can I share my screen? Maybe.
Yeah, that is fine.
Okay. Mm, just is my screen visible to everyone? Like,
No.
okay, okay, just a moment. Is it visible now?
No, not yet.
Uh, let's just wait for a moment.
Yeah, yeah, I think we can see your screen now.
Yeah, okay. So, so I think everyone is could see my screen. So, okay, so I'll continue. Cool. Yeah. So, yeah, so I'll continue. So let's talk about the embeddings part. So there are many choices for the embedding. So people mostly use Glove for embedding today. Like, so Glove is just a word vector that is freely available on this website. which is provided by Stanford. But Glove has like lots of like disadvantages, something. So, for example, to give you some motivation, like let's look at these. Um, um, just a moment. Yeah. So if you see this like funny image, like so the person is asking like what is the embedding for the word stick, and the he says that you should use it in a sentence, and the embedding of stick changes when you are using in a sentence, and it will be a different embedding when you use it in a different sentence. So the main motivation behind Elmo is like it takes context into account. For example, stick can have a meaning like rod, a long rod kind of thing, or stick can also have a meaning like let's stick to something or let's stick to someone, something like that. So Elmo basically takes care of that fact where you have a context, and the context defines what the embedding of the word will be. So when you use it in a different sentence, the embedding of the word changes, and that is very much like useful for um, complex tasks like question answering, passage ranking, and of course our AI challenge that we have provided. So these kind of vectors like Elmo and the last one like BERT is very helpful in this task. So these all takes care of the context. Whereas for Glove, what happens is that whenever you give a particular word, it always gives you a constant embedding for that. But in Elmo and BERT, you have to give the whole sentence, and based on the sentence, it will give you the respective word embeddings. So if you give a different sentence, the embedding of the same word will be different in that new sentence. Uh, so Elmo is like freely available, like you can go and have a look. It's by Alan AI. You can have a look at their website. So Elmo take cares of these three factors: contextual, deep, and character based. Contextual is the same thing that I just explained, that the embedding changes based on the context. Deep, it is because that the Elmo representations are pre-trained vectors that are part of a big deep neural model, which is trained for language model. And once the neural model got trained, the intermediate layers representation is given as a free vectors. So the third point is that it's character based, which means that even if some word doesn't exist in your vocabulary, it will always give a vector because the characters are always known. So this takes care of many useful cases where you want the embedding of the word bad and badly to be very similar, right? But unfortunately, these two words are different words in a vocabulary, like bad and badly. But when you use a character-based model, it takes care of the character overlap between bad and badly. So these morphological rules which appears in bad and badly, slow and slowly. So this is being taken care of by character-based models. And also one common issue that we have today is like out of vocabulary error. When a new word comes and we don't have any embedding for that, it always gives out of vocabulary error. But with embedding like Elmo, it will never give you out of vocab error because it is trained on characters and not just on words. So these are few benefits that you will get with Elmo embedding, and in the challenge also you should use this Elmo or BERT uh, embedding, and maybe not Glove. Um, So BERT is a very interesting model. It's a deep language model which is trained on lots of textual data from web, which means that so language modeling is a very useful task in today's NLP, where you try to predict the next word in your text. Um, so most of the embeddings are like word to wake, Glove are all language models. So BERT is also one such language model, but it is completely based on neural network where it is trained on a large amount of data, and it's a huge model with like 24 deep layers. And the model is basically known as transformer. Like transformer might be a very new thing to you, but transformer is something that is mostly used for translating sentences. Like it's mostly a state of the art model for translating sentences. So the authors like found out that using a very deep model for language modeling and then reusing the vectors for other tasks like question answering or sentiment analysis is very helpful. So BERT is one such model that you should use. So BERT and ELMO will definitely give you a very good gain. Um, so this is a very nice article that I have shared here, and you should have a look at it. This is the same article as this one. So these will give you a very good tutorial of how BERT and ELMO works. So as I said that this domain is particularly known as transfer learning because you train a huge model in one task where you have a lots of data, and then after you train it, you use the pre-trained vectors as embeddings for other tasks like the the AI challenge that you also you have provided. So these BERT and Elmo are all pre-trained embeddings that you can use, and it will definitely give you a very good jump in your scores. Uh, you can choose to use DSSM or CDSSM vectors. Like these are sentence level vectors. They are not word level vectors. So if you want to uh, get vectors for the whole sentence or the whole paragraph or the whole question, you can just use DSSM or CDSSM vectors. They will not give you embedding for a word, but they will give you embedding for the whole sentence. So this is the download link. You can download it from here and you can start using it. It's pretty easy to use. So this is mostly the choice of embeddings that are given. Like you can try to use from these embeddings. So uh, I will suggest you should use Elmo and BERT because these are like state of the art like embeddings. Like as you can see from Elmo's result, like these are all different NLP tasks where Elmo is being used, and they have given a very good score already. So Elmo was trained on a large corpus of text, and the same embeddings are now used in different other tasks. So they have also mentioned the increase in the scores also, and you can see there are like a noticeable increase. So you can use the Elmo for sure, or you can use maybe BERT also. This is the BERT repository. Uh, you can Yeah, so you can see that BERT is being used in many models, many tasks like Squad. Squad is a question answering task. So you can see BERT has given a very good score. And so these basically proves that just using a very good embedding can help you get a very good score rather than a very complicated model, which is very expensive to build and to train. So, so one first point is that always use a very good embedding. Few tips regarding handling the data. For example, so the data that we have shared has like 10 passages for one query, and so you can try to use maybe only three negative passages and not all of the negative passages. That will help you to get a very good score at a very early stage. One common practice that we do is that we try to take a small subset of the data and try to train for longer and longer time so that it finally overfits. So this is a basic check that we do to see if the model is at least showing some indication that it will work in future. So you can try this test. It is very advisable for any ML problem or any NLP problem using machine learning or deep learning. So this is kind of sanity check that you should do. The third point, which is one of the most important point that you should take care of, is that many people might treat the problem as a binary classification problem where you are getting scored for a query passage pair. That is actually a very problematic thing, because that introduces a large number of class imbalance, because you have many negative passages in the data and just one positive passage per query. So if you just treat it as a binary classification problem, the negative pair count will be too much than the positive examples. So what you can do is that you can give scores to all the 10 passages based on the query. The scores will be given based on what model you use, and then treat it as a multi-class classification problem, right? For example, in multi-class classification, you have 10 classes, you give scores to each of the classes, and you then take the maximum class. So you have a multi-class classification loss that you use using softmax. So you can frame the problem similar to that, where you give score to 10 passages and then treat the 10 passages as 10 classes and do a multi-class classification problem. This will not only help in improving the score, but it will also help in battling with class imbalance and lots of negative data, that problems. The fourth one is, of course, like using Elmo and BERT, which is based on context, and not try to avoid like Glove, which many people uses, but this is not based on context. So like words have multiple meaning when used in different contexts. So we all know that. So these are the four tips that I will share, maybe to tackle or to handle the data in a much better way. And it is highly advisable that before going into the model building part, try to uh, try to make good use of the data, try to take a subset of the data so that you know what your model is doing or what the data is behaving like. So first, try to ensure that you are using a very good quality data, good quality subset of the data. And then when you are sure that everything is working good, you can try to increase the data and train it on much more data so that you can get a better score. Uh, Next, I will talk about some good ideas for deep models that you can try. Uh, Harish has given you a basic understanding of how you should compute the features from different NLP by using different NLP techniques like tokenization, stemming, NER. In addition to that, you can use these deep models, deep features that you can use to enhance your scores. So it can be as basic as the first one, where the left side is the query and the right side is the passage, and you can encode all of them using a bi LSTM, which is bidirectional LSTM. And once you get the vectors for all the query and passage words, you can do a pooling on top of it. Pooling is basically like taking the average value from all of the vectors, and pooling gives you a single vector. And once you get a single vector here, you can just classify it on according to 0 or 1. 1 is, of course, when the passage is answering the query or is relevant for the query, and 0 is like when it is not relevant. So it's a simple deep model that you can try. It's very easy to build. It will give you some jump in the scores, like encoding all query and passage using LSTMs and doing a pooling to get a final vector, and then just classifying it. One thing to make sure is that before encoding using LSTM, you have to give some embedding at the initial stage. You can ensure that you use the Elmo and BERT that I just described. The next thing, which is much challenging, is using attention. So attention is a very simple concept. Which means that you can match each query word with a specific passage word to get scores. So this score is basically how well a query word is relevant to a passage word. For example, how long in query can be very relevant to something like 6 to 7 months in passage. So this association can be automatically learned from data using attention. So this removes the need for using manual features sometimes, like if the query is asking for a year or if the query is asking for a person's name. These manual features you can sometimes replace by using attention, because attention automatically learns the association between query words and passage words. This is a small image that you can that I will use to explain how attention mostly works. Like you have a question, you have a passage. Question consists of 2 words, passage consists of 3 words, and each word in the question is matched with each word in the passage. For example, UQ1 will be matched with UP1, and then will be matched with UP2 and UP3. Same in similar manner, UQ2 will be matched with UP1, UP2, and UP3. So after each matching, you will get a score. Like these will give you a score of like how important is this query word for this passage word. So these will help you in learning associations between words. So once you learn these scores, you can create a new representation for the passage, which is uh, aware of what query contains. So initially, this passage representation which you started with didn't know anything about query, but after using attention, you can fuse information from query into passage. Uh, so this is how attention works. Uh, and you can create more and more deep representations by adding more layers. And finally, you can do a mean pooling like this, as I showed in the previous image, to get a classification score of whether the passage is relevant or not. To give some motivation, this is how attention looks like. So let me just, yeah, so this is how attention looks like. If you see, in the left hand side, you have a question like how long does it take to recover from a shoulder surgery? In the right hand side, you have passage. The recovery time for shoulder surgery is about 6 to 7 months. Uh, dot dot dot. And if you see, attention has like given you scores between each word in the query with each word in the passage. So, for example, if you see long in query is most matched with 6 to 7 months in passage. And that's why this region is dark in nature, because the score here is very high. So, so the attention and has automatically learned from the data that whenever a question contains the word long, the model should be looking for something of a duration or some numeric answer from the passage. Uh, so these will help in understanding if the passage is relevant for the query or not. When a passage is not relevant for the query, uh, every cell will be like light color, will like give you a very low score. Um, so uh, to summarize, you should use a proper embedding like Elmo and Bird. Elmo and Bird both works on context, unlike Glove. And you can try to use sentence level embeddings also, but I'll still suggest you go with Elmo and BERT because these are the state of the art models. because they are already coming from a huge pre-trained model which is trained on a large corpus. Try to use less number of negative passages, like maybe 3 or 4 rather than all the 9 negative passages. Try to use a subset of data and try to see if it overfits. If it overfits, then it's a good sign that you are going in the right direction. And of course, try to treat it as a multi-class classification problem as opposed to a binary class classification problem, which most people do. Uh, that is very hard to train and will give you low scores than using multi-class classification. Um, when you are entering the when you are trying to use deep models, try to start with the basic one, maybe without attention, like encoding query and passage using bi-LSTM. Make sure that you use bi-LSTM because passages are very long in nature. And once you encode, you can use a mean pooling kind of technique to compress it into a single vector and classify. Uh, you can use attention to form matching scores between query words and passage words as well. And then on top of that, you can build more and more layers using LSTM, just like the first image. And at the end, you can do a min pooling to get a final score. And as you can see, attention helps a lot in visualizing how important a query word is for a passage word. So these are the few techniques when you are working out with deep learning that will help you give a very good score. But I will suggest you use the deep features in addition to the uh, traditional NLP features that Harish explained, so that you can take best of both the worlds. Um, yeah, so I think we are mostly done with the presentation. Like we will be free to take some maybe questions from you guys, any doubts that you might have, and we can maybe answer those. Harish, are you there?
Yes, yes.
Yeah.
Yeah, so yeah. Is anybody asking question? No, I think you can ask, like you can use your microphone now and ask. That should be fine.
Actually, my question was, thank you for giving me opportunity for for questioning. As we can see, deep learning models can perform far better than other models. Can you please suggest us a few papers so that we can learn how the other models, similar models, are working, and uh, and also the suggestion about the last slide that you were talking about.
Okay.
Okay.
So I wanted to get some kind of paper so that we can learn it more regressively.
So we'll be sharing like the presentation, and we'll be sharing also like many resources that you might find helpful,
Yeah.
like how like where this attention thing came from, like which papers uses these. Like so, this is one technique that mostly every models today use. So to answer your question, like we'll be sharing many useful papers and resources that explains this in a more depth.
Okay, thank you. That's what I was asking. because in the slide you only showed us the basic efficient models, and where you were saying about what is mean pooling and BLSTM, and so many other things like how to match passes between questions. But if there is a state of art model that is already available, like we do in CNN, like we use unet or lxnet to make our model more closer to them, to make it more productive, or as you can understand what I'm saying. So is there any other benchmark models or some state of art other than that you showed as embeddings?
So to to know more about question answering and what all the models do, you can go to this website. So I'm assuming that my screen is still visible.
Yes, yes, it is.
Uh, so there are two websites that you can visit. One is like Squad is there. So you can try few things like Squad. So I mentioned Squad while explaining Elmo. So Squad is a very interesting question answering data set that is provided by Stanford. And if you go to the leaderboard section, so these are all benchmarks that people mostly use. Like if you can see, Squad is a question answering data set. The problem is not same as the challenge that we provided, but it's very similar. Like you have to find the answer, so you have to. It's very similar. These are
Yes,
all.
this is much helpful.
Yeah, yeah. So you can see many papers link also given there. So you can go ahead and read the paper. You have scores. This is the best paper till now. It has this score. This was the human performance, which is still unbeaten. So it's so this is one of the most important website that you can go and have a look at all the benchmarks.
Thanks, looks helpful. I will surely check it out. Thank you.
Welcome.
Yes. So do we have any other question? Oh, okay, then I think we can end this session. So
Okay.
thank you all. Uh, all the best for the competition.